Nice to meet you. I'm Khazar Joktai and you're watching my YouTube channel, School of Advanced Chemistry. Today, I'm going to discuss how to balance a redox equation by oxidation number method. Let's get started. For example, I'm having an equation that is reaction of copper with nitric acid. Cu plus HNO3 goes to CuNO3 twice plus NO2 plus H2O. And I'm going to balance this equation with the help of oxidation number method. And this is a redox reaction or redox equation. First of all, the first step, the main step is to find the oxidation numbers, oxidation states of each and every element. Those are present in this equation. So first of all, I'm going to find oxidation state of each and every element in this equation. Let's see over here. In case of copper, it is a pure element and its oxidation number is equal to 0. In case of HNO3, here are three elements and this HNO3 is a neutral molecule. So the sum of these three elements must be equal to 0. Sum of the oxidation number of these three elements must be equal to 0. So first of all, in case of oxygen or hydrogen, hydrogen is equal to +1. Oxygen is equal to -2. Here are three oxygens, so sum will be -6 over here. And in this box, to make sum is equal to 0, we will write +5. Now come towards copper nitrate. You know that overall a nitrate ion, NO3, one negative ion. The nitrate ion, that is a one negative ion, it is also having one minus oxidation state. So this number is basically its charge as well as its oxidation state. So here are two nitrates. So I'm going to write -2 over here. One nitrate is equal to -1. Here are two nitrates, so it will be equal to -2. To make sum equal to 0, I will have to write +2 for copper. So in this case, copper is having +2 oxidation state. Now come towards nitrogen dioxide. In case of nitrogen dioxide, I'm dividing into two parts because there are two types of elements. In case of oxygen, as you know, oxygen in this case that is showing -2 oxidation state or oxidation number. So it is equal to -4 over here. And to make sum equal to 0 for NO2, we will write +4 for nitrogen. +4 for nitrogen. Come towards H2O, -2 for oxygen. So +2 for two hydrogen and +1 for one hydrogen. So that was step number 1. We have marked different oxidation state on almost all species. Now come towards, let me compare the oxidation state of different element before and after the chemical reaction. I mean, initially copper is having 0 oxidation state, but finally when it is completed, it has made copper nitrate. So copper is +2. Copper is +2. So come towards the next one. In case of hydrogen, it is +1. And here hydrogen is also having same +1. There is no change. In case of oxygen, one oxygen is -2 in this case, as -6 is the answer of 3 oxygen. And come towards this one. Here again, one oxygen is equal to -2. Here, one oxygen is equal to -2. And you can see that this whole nitrate ion is present in the reactant. And again, this whole nitrate ion is also present in the product. So there is no change in the oxidation state between nitrate ions to nitrate ion. So oxygen is not going to change its oxidation number. Hydrogen is not going to change its oxidation number. Copper is going to change its oxidation number. The last, it's turn for nitrogen. So in this case, in case of nitrogen of nitrate to this one nitrate, there is no change. But when we are going to compare this nitrate with this NO2, there is change in oxidation state of nitrogen. Initially, it was having plus 5, but now it is having plus 4. So there is change of one electron. I mean, there is gain of one electron. So one electron is going to be gain over here. And you know, what about copper? It's going to lose two electron. So the next step is, so we have find that there is loss and gain of electron. It is a redox reaction. I mean, copper is losing two electron, but the nitrogen is gaining one electron. So the basic theme is we are going to equalize these two numbers. So I'm going to reciprocate these numbers. I'm going to multiply this green number with the white arrow species. I mean, I'm going to multiply HNO3 by 2. I'm going to multiply by NO2 by 2 and reverse for green arrow species. I'm going to multiply by 1 to this copper. I'm going to multiply by 1 to this copper nitrate. So we have find basic numbers for multiplication. Initial number of multiplication, I mean, so what is the basic advantage or advantages of finding these number? The basic advantages, you are bound to use the 2 to write 2 over here, 4 over here, 6 over here. I mean, you will write the multiple of 2 over here. You are not allowed to write 3 over here. You cannot put 3 over here. You cannot put 5. I mean, you cannot put odd numbers over here. Same is the case over here. In this case, in case of NO2, you will write only even number. I mean, the table of 2 will be applicable with NO2, and same is the case with HNO3. I'm going to write this equation once again. Copper plus 2 mole of HNO3 goes to 1 mole of CuNO3 twice plus 2 mole of NO2 plus 1 mole of H2O. So now the next step is, you can say it's step number 2. The next step is to balance the equation by simple mechanism, by simple method, by balancing the atom. So let me check hydrogen. 2 hydrogens over here, 2 hydrogens are over here. So it's balanced. Hydrogens are balanced. Come towards nitrogen. Here are 2 nitrogen, but here 2 plus 2, 4 nitrogens are lying on the right hand side. So we can write 4 over here to balance the nitrogen. 4 over here to balance the nitrogen atom. So the step 2, I am balancing all the atoms manually, simply by the simple mechanism. Now nitrogen is balanced and I'm going to change hydrogen. Now these are, again, we have increased the hydrogen. So 4 hydrogen should be on the right hand side as well. So hydrogens are balanced, nitrogen are balanced on both sides. Now it's turn for the oxygen. 4 threes are 12. 12 oxygens are over here. 2 threes are 6 oxygen. 2 twos are 4 oxygen. And 2 ones are 2. So 6 plus 4 plus 2. Yes, 12 oxygens are over here. Oxygens are balanced. Hydrogen balanced. Nitrogens are balanced. Oxygens are balanced. Finally, what about the copper? At the end, we will check the element. Pure element will be treated at the end of this mechanism. One copper, and equation is balanced. So overall equation is 1 mole of copper will react with the 4 mole of HNO3 to produce 1 mole of copper nitrate, 2 mole of nitrogen dioxide, and 2 mole of H2O, this is said to be a balanced equation, and I made it balanced by oxidation number method. Now come towards another example. H2SO4 and plus HI goes to H2S plus I2 plus H2O. So I'm going to balance this equation again by oxidation number method. I mean by balancing the loss and gain of electron. So first of all, the first step, as you know, the first step is to mark their oxidation number. In case of H2SO4, three elements are over here. Plus 2 for hydrogen, minus 8 for oxygen, because 4 oxygen atoms are over here. 1 oxygen is equal to minus 2 oxidation state. So making sum equal to 0 on this H2SO4, I'm going to write plus 6 for sulfur. In case of HI, hydrogen iodide, hydrogen is always positive 1, and so obviously it will be minus 1 for iodine. In case of H2S hydrogen sulfide, plus 2 for hydrogen, 1H is equal to plus 1. So, I mean, that is 1H is equal to plus 1. For 2, it will be plus 2. For sulfur, it will be equal to minus 2. This is the pure element, so its oxidation number will be equal to 0. In case of water, H2O, plus 2 over here, as you know, plus 1 is for hydrogen, and here minus 2 will be for oxygen. So let me check what is happening before and after the reaction with these elements. There is no change in hydrogen. It's plus 1 basically. Initially plus 1, finally plus 1, finally plus 1. So there is no change in oxidation state or oxidation number of hydrogen. Come towards sulfur. Initially it is plus 6 and finally it is moving to minus 2. So there is change in oxidation number. What is the change in oxidation number? It's equal to minus 2. It is a final minus initial minus is plus 6. So the basic answer is that is equal to minus 8. Overall answer is minus 8. Mean it has gain 8 electrons. It has gained 8 electrons. What is happening to the oxygen? In this case, oxygen is minus 2. 1 oxygen is equal to minus 2. And finally here it's also minus 2. So there is again no change in the oxygen state of oxygen. The last one is iodine. Let me check its change. I'm writing it with a green pen. Minus 1 to 0. So there is change in 1 electron. There is loss of 1 electron. You know, here is the gain of 8 electron and here is the loss of 1 electron. So I'm going to reciprocate these number with green arrow species and with a yellow arrow species. So I'm multiplying this yellow arrow species by 1 and I'm multiplying green arrow by 8. So I am putting 8 over here, and as you know it's an element, there is no need to write 8, 4 and any number as it is balanced at the end of a chemical reaction. So basically I am going to put 8 over here. So what is the next step? Next step is to balance the atom by manual method. H2SO4, 8Hi goes to H2S plus I2 plus H2O. So first of all, let me balance the sulfur, and sulfur is balanced at the moment over here. Now come towards iodine. 8 iodine, here is I2, I'm putting 4 over here, or you can balance it at the end of a balance, at the end of a reaction, at the end of equation, I mean. Next thing is hydrogen. 2 hydrogens are lying over here, 2 overall 4, and 2 hydrogen over here, 8. Overall 10 hydrogens on the left hand side. 2 plus 8 is equal to 10 hydrogen. Here the hydrogen is equal to basically 2 plus 2, 4. I'm multiplying 4 over here to balance this. So 2 4s are 8 and 2 hydrogens are balanced. 2 4s are 8 and 8 iodines are balanced. and one sulfur, sulfur is balanced. So this is the final balanced equation. 1 mole of H2SO4 is going to react with 8 mole of HI to give 1 mole of H2S, 4 mole of iodine, and 4 mole of H2O. That is the balanced chemical equation, and it has been balanced by oxidation number method. Come towards another example. For example, when Cl2 is allowed to react with sodium hydroxide to make NaCl, NaClO3, and H2O. This is a special redox reaction that is said to be disproportionation reaction. Disproportionation reaction. So once again, first of all, the first step is to find the oxidation state of each and every element. As I told you, this is a disproportionation reaction. It is a reaction in which same species, some molecule of the same species are going to oxidize and same species molecule are going to reduce as well. These are the unique type of redox reaction. First of all, Cl is equal to 0. In case of NaOH, the whole OH is equal to -1. Sodium is +1. In case of NaCl, Na +1 and Cl is -1. In case of NaClO3, three elements are over here. I'm putting +1 for sodium, it is fixed. For oxygen, it will be -6 because one oxygen is equal to -2. I mean, it's fixed. And to make sum equal to 0 on NaClO3, we will mark +5 over here. In case of H2O, one hydrogen is equal to +1. But here are two hydrogens, so I will write +2 over here, and for oxygen -2 over here. Now, there is no change in oxidation state of sodium. There is no change in oxidation state of oxygen. Oxygen is remaining same. It is -2 over here and +1 for hydrogen over here. I mean, oxygen is same. Hydrogen is +1. It is again +1. So hydrogen also not going to change itself. So it is constant. I mean, it's same. What is the change in oxidation state and which element is going to change? Number one, Cl2. This chlorine is changing itself. It is moving first in -1. So this is called reduction. And here is basically addition of one electron. The same Cl2 is going to change into Cl +5. And here is the exchange of, or you can say the loss of 5 electrons. So I'm going to reciprocate this number, these numbers 1 and 5, and I'm going to multiply other arrows. First of all, let me write it over here. I mean, first of all, let me mark 5. I will write 5 over here. Sorry. I will write 5 over here with the green arrows, and I'm not writing 5 over here because it is a pure element. Left it like that. It will be balanced at the end of an equation. And let me mark 1. I mean, as you know, there's no need to mark 1. However, let me mark 1. I'm going to mark 1 over here and initially 1 over here. So 1 over here and not 1 over here. I mean 1 over here and 1 over here. Again, there's no need to write 1 over here. So initially we are starting with 5 mole of NaCl and Cl2. So initially I'm going to have 1 mole of Cl2, NaOH, 5 mole of NaCl, 1 mole of NaClO3, and 1 mole of H2O, 5 mole of NaCl, initially 1 mole, and its element that is having initially 1 mole as well. 6 sodium are over here. So first of all, I'm trying to balance the sodium. So I'm going to write 6 over here to balance the sodium. Now it's turn to balance oxygen, hydrogen, then Cl, as it is an element, it will be balanced at the end of the mechanism. So in this case, how many oxygens are there? Three oxygens are over here and one, four oxygen, but here are six oxygen. To make or to balance the oxygen, I'm not disturbing this number. I'm multiplying H2O by 3. So 3 oxygen over here, 3 over here, 6 oxygen are balanced, sodium are also balanced. By multiplying 3 over here, hydrogen are also be going to be balanced. So hydrogen 6 over here, hydrogen 6 over here, hydrogens are balanced, oxygen balanced, sodium balanced. Now let me balance the element Cl2. How many chlorines are lying on the right hand side? 1 Cl and 5, 6 Cl, and I'm putting 3 Cl2. I'm putting 3 Cl2. I'm multiplying Cl2 by 3 to make this equation balance. So finally, 3 Cl2 plus 6 mole of NaOH goes to 5 mole of NaCl, 1 mole of NaClO3, and 3 mole of H2O. So this is the balanced equation, and so on. Now come to us another example. MnO2 plus HBr goes to Br2 and plus MnBr2 plus H2O. Once again, step number 1 is to find the oxidation number of each and every element. So in first step, I'm going to mark oxidation state. For oxygen, I'm going to mark first for oxygen because it is confirmed that in this case, oxygen is equal to -2. So -2 into 2, -4. And Mn will be equal to +4 to make sum equal to 0. In case of HBr, obviously hydrogen is confirmed. Its number is +1. So to make sum equal to 0, I will mark -1 over here. In case of bromine Br2, I'm going to mark 0 over here. Br2 is a pure element, so its number will be 0. In case of MnBr2, in this case, when halogen is present with a metal, then it's going to show -1 oxidation state. If it is present only with a single metal, so it is by default, it is going to have -1 oxidation state. So -2 over here and +2 for manganese. The last one, H2O, -2 for oxygen, +1 for one hydrogen, overall +2 will be over here. So let me check. Now, second step is to check before and after the change in oxidation state. In case of manganese, initially +4, finally +2. So basically it has gained 2 electrons. 2 electrons have been gained by Mn2. There is no change in hydrogen oxidation state. There is no change in oxygen state of oxygen. And now come towards Br. Br is changing its oxidation state. Let me change the color of my arrow, pen. Br -1 to 0, and the change in 1 over here. And if I'm going to consider this Br to this Br, and again in this case 1 Br is showing -1, so there is no change. So only 2 changes are over here. This is called reduction, and reduction, and it is called oxidation. Oxidation, reduction, and oxidation. Now the last step is to reciprocate these numbers. Let me mark the numbers again. 1 over here and 1 over here. Now, the other species will be marked by 2 numbers. I will mark 2 over here and 2 or 1 over here. It's an element, it's a pure element, so it will be balanced at the end of the mechanism. So basically, we will write 2. We will start from 2 mole of HBr, and then you will make this equation balanced by manual method. I'm going to write this overall equation once again. MnO2 plus 2HBr goes to Br2 plus MnBr2 plus H2O. Let me balance this equation manually. 1 Mn, 1 manganese, and 2 oxygen, but here are 1 oxygen, so I'm going to multiply it 2 over here. So manganese, I mean, the first element, that is the manganese, that is balanced. Manganese is balanced, oxygen is balanced, and now it's turn for bromine. Uh, and hydrogen. So 4 hydrogens are over here, but only 2 hydrogens are over here. I can change this 2 into 4. I mean, 2 twos are 4. So I can write 2, 4, 6, 8, and so on. So I'm making 4 over here. And 4 bromine, 2 plus 2 bromine over here. So once again, this is the balanced equation, and it is balanced via or with the help of oxidation number method, or equalizing the loss and gain of electron. That's all about today. Thank you very much. Please subscribe my channel, hit the bell icon, and share it with your friends. Thank you. Thank you very much. Have a nice day.